Hello friends, now the next topic in feedback amplifier is the analysis of voltage series feedback amplifier using Mosfet. So we'll be talking about voltage series feedback amplifier only. In the previous video we have seen the voltage series feedback amplifier using BJT. That circuit I have discussed on basically screen recorder. Now I'll be discussing that circuit using, of course, conventional method, that is using whiteboard. The normal source follower, this is the source follower circuit using Mosfet. Normal source follower circuit is an example of this voltage series feedback amplifier. For analysis of voltage series or for analysis of any feedback amplifier, what are the steps? First, we need to identify the type of topology that is already mentioned to you, voltage series feedback. Then we need to find the beta, gain factor beta. Then we need to identify input and output circuit of the amplifier without feedback loading. And finally, we need to draw the circuit without feedback loading and replace the BJT or MOSFET by its small signal model. These are some of the steps which are used for analysis of the amplifier. So here my first aim is, of course, this is voltage series feedback. How it is identified? Let us see that. Basically, you can see this circuit of any common source or source follower configuration. This circuit, that is the circuit involving gate and source terminal, that circuit, that loop is called input circuit, input loop. The loop involving this output, that is your drain side and source side, you can say this is the loop. This side is output circuit. Fine. Here we are taking output from the source terminal of the MOSFET. So the output voltage, the complete output voltage, when it is node voltage, that is always with respect to ground, that is this voltage. Fine. So that complete voltage is appearing in series with the input loop. When output voltage is appearing in series with the input loop, so that is called series mixing. Fine. So output voltage is basically mixing with the input supply voltage, so that is series mixing. And since we are taking output voltage completely in the input circuit, so we call that as the voltage sampling. So we are taking the sample of output voltage which is mixing with the input supply voltage. So voltage sample voltage mixing or voltage sample series mixing. Voltage mixing is called series mixing. You can see my videos, previous video, you will understand. Voltage mixing is called series mixing and voltage sampling is called shunt sampling. On output side, when it is called sampling, so voltage sampling is shunt sampling, but voltage mixing is series mixing. So this is one circuit which is a voltage series feedback amplifier. So here the voltage which is appearing in the input loop is this voltage, and that is feedback voltage, and output voltage itself is the feedback voltage here, right? So we know what is beta. Beta is the ratio of feedback signal to the output signal. So this is equal to, you know what is VF, that is V naught upon V naught, that is equal to 1. So beta here is 1. Fine. Now I have to identify input and output circuits without feedback loading. I will make you understand how to identify the input and output feedback circuits or input and output circuits without feedback loading. This is any amplifier. This is beta feedback. This is supply. This is output side. So when it comes to voltage sampling, in voltage sampling we take the output voltage. This is output voltage. We take our sample of the output voltage directly to the feedback network, and for series mixing we connect the output of the feedback network in series with the supply voltage. This is supply voltage. Suppose the output of the feedback network is connected in series with the supply voltage, that is series mixing, and when you take output voltage as it is to the input, the output voltage as it is input to the feedback network, this is the feedback network, that is called shunt sampling. So to identify this side, the circuit without feedback loading, so I should not be taking any feedback from here, so I will reduce this output voltage to 0. So that the input to the feedback network is 0 and we identify the input from this side. So what I do, I short this output side so that input, in case of voltage sampling I am talking, for voltage sampling input to the feedback, for voltage sampling what is input to the this feedback network, that is output voltage. So for identification of input circuit without feedback loading, I should reduce input to the feedback network to 0 so that output voltage is made 0 and output voltage can be made 0 by short circuiting it. Now come back to the circuit. For identification of input circuit without feedback loading, here it is voltage sampling because voltage itself is coming, this is basically feedback network itself, that beta itself, fine. So output voltage is coming as a sample. So to identify the input circuit without feedback loading, I need to reduce this to 0. It means that is short it. And when you short it, you can see what is there in the input loop. This is short circuited. So if output is shorted, output terminal is short circuited, then the input circuit is this Vs, then this terminal, and this is bypassed, right? So that is, if you talk about the circuit, so this is the input circuit. I will simply replace this by, I will simply replace RS by short circuit, and that circuit will be the input circuit without feedback loading. This is short it. That's what I'm trying to say. Fine. For identification of input circuit without feedback loading, I should reduce V0 to 0 so that there is nothing input to the, there is no voltage input to the feedback network is 0. So I reduce this output to 0 in voltage series feedback. Let us see how to identify the output circuit without feedback loading. What is output circuit? Output circuit is nothing but the circuit, I'll redraw it like this. Output circuit is what? That is circuit involving the drain and source terminals. This is the output circuit, this circuit. Fine. To identify the output circuit without feedback loading, now see, I need to identify this side, circuit seen from this side without feedback loading. It means whatever current there, whatever current was there, that was say this is feedback network, so this is IF, fine. This is IF and this is the voltage V for voltage series feedback. I'm saying for voltage series feedback, this is VF, this is IF, fine. So this VF voltage here coming to this in voltage series feedback, this was feed voltage at the output, you can say this is plus, this is minus, like this, fine. So to make it so that there is no input to this, fine, I should reduce this for series mixing. So what do we need to do? Please see it carefully. This is what you have. I want to see the circuit from this side. Fine. So in that case, for in case of voltage mixing, I need to reduce this to the coming current coming from this side is 0. If there is no current here, IF, this is IF. So we reduce the input current to 0. In case of series mixing, we reduce this current to 0 so that there is no current in this loop and there is no voltage appearing across this terminal for identification of the circuit from output side. So for identification of input circuit without feedback loading, we put this voltage V0 to 0, and for identification of output circuit without feedback loading, we need to put I in equal to 0, because if I make this 0, there won't be any current into this circuit, because there will not be any current returning, because this is 0, so there won't be current passing through it, right? So there will not be loading from the input side. Fine, there won't be any current from the input side. That's what I'm trying to say. If there is no current, because this current is 0, so this current is 0, this current will be 0. So there is no loading of the circuit from the input side. So that's the circuit seen from the output side is known as the output circuit without feedback loading. In case of series, I need to make current equal to 0. In case of shunt, I need to make voltage equal to 0. If it is series mixing, I need to make current equal to 0. If it is series sampling, I need to make output current equal to 0. Please understand how to identify input and output circuits without feedback loading. In case of series word, I need to make current equal to 0. In case of shunt word, I need to make voltage equal to 0. So it was shunt sampling, it was voltage sampling. In case of shunt sampling or voltage sampling, I need to make voltage equal to 0. In case of series sampling or series mixing, I need to make current equal to 0. So this was series mixing, so I need to make current equal to 0, so that there is no current coming from the input side in the feedback circuit. Fine. So now come back here. So I need to make this current coming from the supply side equal to 0, and for that we need to open the supply. If current here is 0, so the whatever is current here, that same current is passing from this. So the circuit, this resistance Rs will be appearing in the output circuit, and there is no input. So now I can take this output circuit like this. Since there is no current coming from the input side here, I can separate input and output circuits like this. Please see carefully. Here I'll be taking it like this. That resistance which was Rs, the resistance Rs was here like this. This was ground. Say this is terminal X, this is Y, and I was taking output voltage from the terminal X, right? It was like this. Voltage VDD was connected to ground like this. You can take it like this. Either you can take a node voltage, or you can take a battery with respect to ground. This is VDD. That's same thing. Fine. This is same thing. If you take, either you take a node voltage or you connect a battery. Fine. So to show this circuit, so what I take this resistance here instead of this point. So when you take this point here, so this is at ground potential, and the point at ground potential will be Y. This will be removed from here, and this point will be X. So what I have done, I have taken this on the output side, that resistance. Lower end which was connected at ground is Y, and the point which is connected at input is S. And this is battery Vs, and this is input circuit. I have drawn the circuit without feedback loading. If you see the circuit, that was the circuit because Rs was bypassed. So this is input circuit without feedback loading. And if you see this is output circuit, because in current a path of current ID there was Rs. So I have taken that on the output side. So this is output circuit without feedback loading. So there is no feedback path in between two circuits. So on output side Rs is present, on input side Rs is absent. So this is circuit without feedback loading. Fine. I hope you understood how to identify the input and output circuits without feedback loading. But I will repeat, this can be one of the question in engineering services mains or civil services mains. There are little less chances of the question from this directly in engineering services prelims. They can ask the simple question can be, what is beta? Beta is 1. That type of question can be there. Otherwise, you don't have many objective type question based on this circuit. Fine. Now, for analysis purpose, what do we do? Replace the voltage source by voltage source what? Replace the biasing source, DC source, by short circuit or ground. Replace FET or Mosfet by its small signal model. So you have to replace the Mosfet by its small signal model and replace this biasing DC biasing source by the short circuit. So when you replace it by short circuit and of course the MOSFET by its small signal model, let us see the circuit. The circuit will be like this. There will be a current source here like this. This voltage is VGS. VGS here is equal to VS because it is voltage with respect to ground. So this is ground. And there is one resistance here. That resistance is RD or R0. That depends on the textbook given to you. Sometimes they write it like this RD, or sometimes some books like it R0. Fine. So this is equivalent circuit of MOSFET, and what is this current source? That is GM into VGS, and that is VGS. Let it be VGS, and VGS is VS, of course. Fine. Right. And what is the output terminal? Output voltage is this. From this, that is between Y and S. So it has to be this voltage because we take the voltage from X. This is the output voltage of the circuit. Fine. So now what will be current, drain current here? That drain current is coming like this. What is drain current? So this current, which is GM into VGS, is divided into this path and this path. So that current is divided into this path, and this means two parallel path. Current in this is this resistance RD divided by RD plus RS multiplied by GM into VGS. This is the current ID. Fine. So V0 will be equal to, that is RS into ID. Why? Because current is going from down to up. So lower end is plus, upper end is minus. So that is same as output voltage. So this is RS RD GM by RD plus capital RS multiplied by what? Voltage VGS. And you know what is VGS? VGS is equal to VS. So I will simply write it VS. So what is a voltage gain without feedback? AV is output voltage by source voltage, and that is GM RD RS divided by RD plus RS. That's it. This is your gain without feedback loading. Fine. So for identification, for any feedback amplifier, what are the points we need to, what are the parameters we need to identify? We need to identify the voltage gain without feedback loading, one, because it is voltage series feedback amplifier. Voltage series feedback amplifier is voltage amplifier. So in case of voltage amplifier, we need to find voltage gain, output voltage by input voltage. Fine. So for voltage series feedback amplifier, we define the gain, that is voltage gain, because output signal is a voltage and input signal is also a voltage. So we define the voltage gain for voltage series feedback amplifier. Fine. So here now we have obtained the voltage gain without feedback loading. Voltage gain for this circuit, and that was the circuit without feedback loading. Then I need to identify the input resistance, Ri. Input resistance. Fine. And input resistance is resistance between this terminal and this terminal, and this is open. So input resistance without feedback loading is infinite, because this is open terminal. Resistance in by the source is open here. So input resistance without feedback loading is infinite for this circuit. Let us talk about output resistance without feedback loading. How do we identify the output resistance without feedback loading? That is the resistance seen across the output terminals. What are the output terminals? These terminals. So resistance seen across these terminals is the output resistance. The output resistance seen across the terminals, that is output resistance. Fine. Now this is RS. So for identification of output resistance without feedback loading, or for identification of output resistance, what do? We simply replace input source by short circuit. So when you replace input source by short circuit for identification of output resistance, I repeat, please understand, for identification of output resistance, that is the resistance seen across output terminals, the input source should be replaced by the short circuit. Input voltage source should be replaced by the short circuit. So that is replaced by the short circuit. If this is replaced by the short circuit, so this becomes 0. Vs is 0, so Vgs is 0. When Vgs is 0, so this becomes 0. This is voltage dependent current source, so that means this current source behaves like an open circuit. When current of voltage dependent current source is 0, so current is 0. When current is 0, it behaves like an open circuit. So now let us see the resistance from here. So that becomes this resistance in parallel with this. So output resistance without feedback loading is the parallel combination of RD and RS. That is RD RS by RD plus RS. That's it. Now D sensitivity of the amplifier is defined as 1 by AV into beta. That is known as D sensitivity, right? And you know what is AV? I have given that. So 1 plus GM RD RS divided by RD plus RS multiplied by what is beta. For this circuit I have already given, that was 1. So that is D. So voltage gain with feedback is what? Voltage gain without feedback divided by 1 plus AV into beta, or that is AV by D. You know what is AV and you know what is D. You simply put it there. Similarly, input resistance with feedback is what? For voltage series feedback, output is voltage, input is series mixing. For series, wherever there is word series, input resistance increases. And here it is voltage sampling. Voltage sampling is shunt sampling, and in the case of shunt sampling, the output resistance decreases. So in voltage series feedback, input resistance increases, means that will be Ri into 1 plus AV into beta. But whatever is this factor, Ri is infinite, so this will be infinite. Output resistance, here it is voltage sampling is shunt sampling, and in shunt sampling output resistance decreases. That means output resistance with feedback will be R0 by 1 plus AV into beta. So R0, you know, that is RD in parallel with RS. Of course you can put it, this D is this factor. So by putting this and this, you can get the output resistance with feedback. And this can be more, there is always possibility of, you know, the descriptive type of question in engineering services mains and civil services mains. That can be one question in mains exam. There is little less possibility of such type of question in objective type papers, maybe GATE or engineering services prelims. But as far as procedure is concerned, you must be knowing the procedure. So this is all about the voltage series feedback amplifier using Mosfet. So in next video, now we will be talking about the next circuit, and that circuit will be current series feedback amplifier using BJT. So wait for my next video. Thank you very much for watching the video.